Hey y'all, and welcome back to my channel, DIY Electric. I apologize, this first part of this video is going to be a little bit darker than the rest of it because I filmed the rest earlier, and only later when I went to put it together did I realize that I was out of focus for pretty much the whole first part of the video, so bear with me. This video is just going to be kind of a brief explanation of how electricity comes from the utility, from the distribution line that's most likely out by your road, and makes its way into your house, into your main breaker panel there. So I'll go over that a little bit. And hopefully you'll get some use and find it informative. And of course, as always, if I don't cover something that you wanted to know, or maybe you don't understand something that I say and want a little bit further of an explanation, just let me know, and I'll be glad to include that in my next video. So anyway, without further ado, we'll go out and head out to the road and take a look at my transformer. Alright y'all, so what you're looking at is the three-phase distribution that goes past my house, and it doesn't, you don't really have to understand what three-phase is. It's just how electricity is generated. Electricity, voltage and current is a sinusoidal wave, and three phases is just a different angle, so it's just offset. Anyway, don't concern yourself too much with that. That rusty bucket up there is my single-phase transformer, pole-mounted transformer, and it gives 120 volts line to neutral and 240 volts line to line. So what you're seeing is, let's see, let me try and move. I'm going to get a better shot of the of that duplex that's coming into my house. All right, so hopefully you guys can see this pretty good. This is the weatherhead, is what they call it. This is where the electricity comes into my house, above my carport. And you can see that there's 3 wires going in there. There's a insulated conductor on the left. There's a bare metal wire in the middle. That's the neutral. There's another insulated wire conductor on the right. So that's what's coming out of that rusty old transformer that I showed you out by the end of my road. And a transformer, it just steps down the voltage level to what appliances use inside your house. So unless you have, a three-phase service coming in, which most of you don't unless you have, like a machine shop or something of that nature, everything in your house is going to run off of either 120 volts or 240 volts, or you might have, well, I'm not going to get into that, 120 volts or 240 volts. So that's what's coming in off that transformer. So if you go from one of those insulated conductors, sorry guys, there's a dump truck going by. If you go from one of those insulated conductors, if you measured the voltage between one of the insulated conductors and that bare neutral conductor, you'd get 120 volts. If you measured the voltage between one of the insulated conductors to the other insulated conductor, you would get 240 volts. So that is strung from that transformer, right? This duplex goes from that transformer out by the road right into that weatherhead. And now I'll take you over to show you where it goes from there. Okay. Here we are at the meter. So those wires coming down the the weatherhead, they come down through that PVC conduit and they go through this meter. And all this meter is it's measuring the power consumption into your house. So there's little transformers in there, little current transformers, potential transformers. They're measuring the current and the voltage to your house, calculating how much power. Look at that little skink that just crawling around up there in my video. You better not go in there. Anyway, so they're measuring how much power you're using in your house. That's how you get billed. So anyway, now I'll take you to the next step of the process here. Alright, here we are. We're at the service panel. So I showed you the meter outside. So we'll just go step by step, right? I showed you the transformer. It comes in from the transformer, goes straight down through the meter and into this 200 amp service panel. So, right out from that transformer, the electricity comes in here to my service panel. You can see all my breakers in there. So I'm going to take the cover off this panel. You got to be careful doing this, because you could here, I'm going to adjust this a little bit. There you go. You be careful doing this, because you could, you know, potentially hurt yourself pretty bad. Remember what I said, you got to be careful here. So there you go. I'm going to zoom in a little bit. Right there. Right there at the top, at those two lugs, those two metal lugs. You see those two wires? That's coming directly in from the meter. It's running through the meter and into this panel. So what you're seeing is those two insulated conductors right there. So you got 120 volts on the left and 120 volts on the right, and it's coming through that main breaker, that 200 amp breaker right there. So if the current coming through those two conductors was to be greater than 200 amps, that breaker would trip and it would shut off the current flow coming into your house, because it's assuming that if it gets greater than 200 amps coming through there, you have some sort of fault going on in this panel, and it's gonna open up to protect your panel from, you know, burning up, causing greater problems. So now you see these individual circuit breakers. Now let's see, I don't have a lot of room in this to show you because of how many breakers I have in here, but you know what I could do is just take this bottom breaker loose, and that's what I'm going to do. So here, I'm going to carefully take out this bottom breaker to expose what is back behind there. And that's for my generator. So you got to be careful with this, because right, this is okay. Yeah, here we go. All right, y'all. Now you see that copper in there, that copper metal, from where I've taken this circuit breaker loose. So you can see, and what it is I told you that those wires coming in the top, I said there was 120 volts on the left and 120 volts on the right. And what it does, you can see right here, that's directly attached to one side. It says probably the left conductor here, 120 volts. That is connected all the way up to that wire, right? And down here, that is connected to the right wire. It's also 120 volts. So what happens is when you plug in one of these 120 volt circuit breakers into this panel, you are connected directly to that conductor at the top, 120 volt conductor that goes back through the meter, out the weather head, into that transformer out there, right? When you connect one, and they're alternating, right? So you can't really see it because I have so many circuit breakers in here, but this is connected to one 120 volt conductor. This right here is connected to the other 120 volt conductor, and it goes like that all the way up. So all of these breakers are connected directly to one of those 120 volt conductors right in this panel. Now this one that I've taken loose, which is for my generator, that's a 240 volt breaker. And you can see it's twice as wide, and you see the slots in the bottom of it. It goes across both of these, right? Because it's 240 volt. So it goes across both of those, which connects it across both of those conductors coming in, which makes it 240 volts. And if I brought out my multimeter and I touched it across, if I measured the voltage across those two metal pieces right there, copper pieces, you would see 240 volts. Everything in your house is connected back to one of these circuit breakers. So for your receptacles and your lighting, it just depends on how your electrician wired your house. But there's a circuit, and it is going out from here, from this circuit breaker, goes out, down, and you can see this mess of wire here. I'll show you. This is a mess. You know, remember, I didn't wire this house, so don't judge me. It's going out from this circuit breaker, and it's going out, and it's going through your receptacles, it's going through your lights, and it's coming back on the neutral, because that's how electricity works, right? You got to have a complete circuit. So it goes through all your receptacles and your lights, to your fridge, to your oven, to your dryer. Everything that is electrical in your house is coming from that transformer outside, through the weather head, through your meter, into your service panel, through one of these circuit breakers, and it is going into your house and powering all of your devices. It's that simple. I mean, this looks like, oh my goodness, look at all these wires, look at all these circuit breakers. Well, when you break it down, if I took all these out and just had one circuit breaker, it would be really easy to understand, because it's coming from the transformer, it's coming into this panel, it's going out that circuit breaker. And the circuit breakers, all they do, the purpose of these circuit breakers is to protect you from your house burning down, or somebody getting killed, or some of that nature. Big time, mostly your house burning down, as this will still let enough current through to kill you, which is why you have to be careful. I mean, 20 amps is, each one of these little circuit breakers has a number on it, tells you what the current rating is for it, what it'll trip at. But if something happened, if a wire were to come loose and touch up against another wire, or touch up against something metal, or cause a condition to where more current would flow through the wire than the wire is capable of handling, normally it would burn the wire up, start a fire, and burn your house down. But these circuit breakers, their whole purpose is to make sure that doesn't happen. So if that happens, circuit breaker opens up, disconnects the circuit from the transformer out there, essentially, and then you fix it. But that's it. That's how it works. All right, y'all, it's hotter than you know what out here, so if you see me sweating, forgive me. So just to recap, what I showed you was that the electricity, and one thing I didn't mention is you might not actually have a pole mounted transformer out by your road. If you have underground service, instead of having a pole mounted transformer out there, well, you could still have a pole mounted transformer. It might just run underground to your meter instead of overhead like mine does. But you could also have, if it's underground, you might have a pad mounted transformer. So a lot of times they're in a green, a green case. There'll be a green cover on them, and they'll be they could be in plain sight, they could be off to the side, maybe there's some shrubs around them to kind of hide them from view, but it's the same principle, right? So it comes in from your utility, at a really high voltage, and maybe I'll go into that later as to why that's the case. But for now, we'll just leave it at that. It comes to your house at a really high voltage, so it has to go through a transformer to step down that voltage to a usable level, to what your appliances need in your house. 120 volt, 240 volt typically. So it comes through the transformer, steps down that voltage, comes right to the meter on your house, passes through the meter so that the utility knows how much you have to pay them every month, right into your service panel. There's some gnats out here. Through the top breaker, which is usually a 100 amp or 200 amp breaker, and just depends on what size service you have. And then it comes down, and each one of those little circuit breakers in that panel, either the 120 volt or the larger double thick ones, the 240 volt breakers, passes through those, and then it branches out to different parts of your house to power your receptacles, power your lights, power your fridge, power your heater, power your water heater. Whatever it is that uses electricity in your house passes. That's as simple as it is. That's how that works. And you know, we'll talk more in the future about individual circuits and, you know, how they go through the house and how all that works. But that's mainly what I wanted to accomplish with this video, is how the electricity comes from the street into your house. That's it. That's how simple it is. All right, y'all. Well, hopefully, if you had a question about it, I have answered your question. If I didn't, if there's something I didn't cover, if there's something I didn't mention that you're curious about, you just let me know, and I'll try and cover it next time. And also, I know I mentioned my generator, that I have a generator and I have a breaker in my panel for my generator. That's something else I can cover too, is when my power goes out and I hook up my generator, how does that work? How does my generator power my house through that circuit breaker? Well, I'll cover that too in the future. So anyway, thanks for watching, and hope you stick around, hope you learned something, and have a good day, everybody.